So section 12.4 is going to talk about this. Now we're going to talk about volume, okay? We've talked about surface area of prisms, cylinders, pyramids, and cones. Now there's one more solid that we're going to eventually hit on, but they just do one section together. What's this solid that I'm missing?
The sphere.
A sphere. So we'll get to that here in a couple sections. We're going to focus on now volume of those four solids that I listed prior. So the ones we've already talked about surface area of, okay?
Okay.
So this is just a combination day again. We'll notice how we're combining prisms and cylinders. Now, why can we talk about them in the same day? What's their similarities?
Prisms and cylinders both have two bases.
Okay.
And one is a polygon base, the other one is a circle base. But they have very similar features because of that.
And we saw with surface area, their formulas
weren't that different.
Yeah, exactly. So again, another thing to keep in mind, even in the end, we have lots of formulas to learn, so we're going to add this to our formula list. But again, think about what do they have in common. Now, before we actually talk about how to find the volume of a prism and cylinder, let's talk about exactly what is volume, all right? So volume of a solid, notice it says it's the number of cubic units contained in its interior.
Okay.
Okay, so, anything that's three-dimensional has a volume. So it's basically the stuff inside of it. All right.
All right.
So anything like if you have your bottled water, the water inside, that amount of water you can fit in it is the volume of it, cubic units. All right. So we have a good visual of this. When you deal with labeling with volume, you're talking about cubic units. So cubic meters, or you might see feet cubed. You might write it like that, okay? So just keep that in mind. There's some differences. So how much stuff is inside of that three-dimensional solid?
Right. And a lot of times when we're talking about, like, for example, when we're talking about a linear unit, we don't put it, we just say, like, feet.
Yes.
Because it's just a single dimension. When you have a two-dimensional space, like area, we see it as, like, feet squared because you're looking at filling up two dimensions. This is filling up a three-dimensional shape.
Yes.
So then now we're going to have this feet cubed.
Very good. Okay. So we're going to talk about different types of volume information, so kind of stay with us here.
All right. First of all, volume of a cube. When we're talking about a cube, now, a cube is a very special type of prism. Tell me about a cube.
Well, a cube is that regular type of prism. It has all of the faces and bases are squares. So all of the polygons, every face that you have, are all squares.
Right. So when you're looking at the dimensions, this example, the picture that we had here was not a cube because it would have to be a 5 by 5 by 5 to be a cube, or a 3 by 3 by 3. So they have to be the same measures on every single edge.
Okay? Exactly.
Now, the volume of a cube is the cube of the length of its sides. So we're going to be learning a formula in a minute to talk about any prism.
Any prism, yeah.
But a cube is very special because all of the units are the same. To find the volume of a cube, I could just take that side length cubed.
Okay.
Okay? And we've talked about cubing things in algebra before, so hopefully that's not anything crazy.
Well, and when you're talking about volume, you're talking about how many cubic units. So basically how many cubes can fit inside of a solid.
Right. Exactly. Okay. Now, the volume congruence postulate says that if I have two polyhedra that are congruent, so any two solids that are congruent, okay, then they will have the same volume, which kind of makes sense. If they're congruent solids of any sort, really, they should have congruent volumes too.
Yeah.
The volume addition postulate says that if I have, well, let me just read it first. It says the volume of a solid is the sum of the volumes of all of its non-overlapping parts. Here's the thing. If you have weird solids, maybe you have like I don't know, I'm going to see what I can draw here. A cylinder that has a cone on top of it. Okay? You're going to be able to find the volume of the cylinder, the volume of the cone, and add them together.
Okay, that makes sense.
So it's just when you have overlap or solids that are next to each other. Like we looked at the cake example on our homework the other day. They were icing a cake. we weren't doing volume, but if I was finding the volume of that, I'd find the volume of the bottom layer and the volume of the top layer and add them together.
And when you're saying non-overlapping, because if they overlap, then you would be including too much volume. You'll be like doubling that overlapping part.
Right.
So things that not overlapping.
Right. Only include them once.
Okay. So let's just get some practice real quick. All right. It says find the volume of a cube with side lengths of 5. Now, I know you guys can do this. So go ahead and do it. Hit pause, check with us.
All right.
So when it says volume of a cube, what's the formula we're using?
The volume is the side length cubed.
And notice again, guys, that first initial thing is when I see what it's asking, it says find the volume of a cube, I'm going to write down that formula. Because in the end, when we take this chapter test, you're going to have all these different solids, volume and surface area. So it's easy to mix up the ideas, okay? Now,
and one thing just I want to stress on your formula sheets, don't just be writing S equals, S equals, V equals. Make sure you identify what those volumes and what those surface areas are of.
Exactly.
Noticed a couple of formula sheets where they just had letters, but like the S equals, but they didn't say what it was the surface area of.
Okay, so this volume of a cube is this formula. They give you the side lengths of 5. So basically I can just substitute that in and cube it. Now, a couple ways you can type this in. You could just put 5 times 5 times 5. Or you could use the exponent button, so and that's what I would do. So 5 to the third power, which is 125. Now there's no labeling, so you could say units cubed if you wanted to. All right,
sounds
so
good.
that's something to be aware of. All right, now reading the next one.
All right,
It says find the side lengths of a cube with a volume of 343. Now I still see we're dealing with a cube and we're dealing with volume. So let me write down that formula. Now, what's kind of different about this one than the last one?
Well, this one they're giving us the volume and we're finding the side length. So I'm going to put in place of V the 343.
So I know the volume and we're trying to find the side length.
And we know it's the side length cube. So we need to undo a cube, which we've undone squares before by square rooting.
And if you had something that was like, let's say side squared, how did you undo that? You said take the square root.
Exactly.
Now, square root undoes something that's squared. So you're not going to square root something that's cubed because it doesn't undo the whole thing.
Right.
Okay? So there is something that we call, and I'm going to make a little side note. You notice how we said square root? Well, that's because something was squared. We call it the cube root. All right? And basically what a cube root looks like, and you guys need to have your calculator out so you can look at it.
Yes.
All right? What it looks like when you do it, I'm going to show you kind of what it looks like without your calculator because your calculator doesn't actually show it like that. Cube root looks like the square root, but it has the little power of 3 like next to it. That's saying take the cube root, and I'm going to do it to both sides. Now, in your calculator, I'm going to have Ms. Hograby kind of talk about this since she's got it in front of you.
Yes, if you look at your calculator buttons, where you have your like x squared button, right above that, if you hit second x squared, it gives you a square root. So when we wanted to cube something, we used the little caret button, which Ms. Palermo is going to draw a picture of the caret button on there for me. It's right above the square root. So if you look right above that, the second and then the caret button, you're going to notice it says x radical.
So I'm going to hit the second, that caret button, and what that gives you, this is what it looks like.
So what that allows you to do is it allows you to tell what root you want to take of that number.
Now, we have an x here. We want this to be the cube root. So can I just type in the second, that caret button, and have the cube root automatically?
No, because it doesn't know what root we want.
Okay.
Because just like there's cube roots, there's also fourth roots and fifth roots and sixth roots.
Okay.
So you can undo any exponent with that x radical button.
Okay, so how do I communicate that I want that to be the cube root?
So we're going to type in a 3 first.
So I'm going to show you kind of, this is what you're going to do. You're going to hit the 3.
And then you're going to do the second and the caret, which is going to bring up your x radical.
And basically what this is going to look like, it's going to look like a 3x radical. Now, that doesn't mean you're taking 3 times radical. This is saying put this in for that exponent, basically.
Right.
Okay.
And then you would type in your 343.
And then what that's going to look like, it's going to give you, this one is an exact answer. The side length is 7, so this is 7 units. Now, checking this, if I put 7 cubed, I should get 343.
Yep.
All right. Now, try the next one on your own, and then we'll check. So we're finding side lengths again of a cube, dealing with the volume of 100. So I know the volume formula again, just keep reminding myself of that. They know the 100 is the volume. Now, the kind of work that you're going to show us, guys, just because this is kind of a newer idea, we want to see that you're taking the cube root. So show this, all right? This will cancel out. And when you take the cube root of 100, now this isn't going to be exact.
No, it's about 4.64.
And we'll be okay with you leaving a rounded answer on that one.
Yeah.
Now, this idea of cube root and things like that, this is something you're going to see again when we get to a sphere. Okay,
Yes.
so just something to be aware of. All right, now let's get to volume more of prisms and cylinders. That's our focus today as well.
All right, we have a few theorems that we're going to be talking about, and some of the theorems are really just the formulas that we're going to be using. First of all, this idea of Cavaliere's principle. And it says if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So if you notice up here, what is this first picture a picture of?
It looks like a right prism to me.
It looks like a right prism. All right, it's nothing is marked, but I do
the right
notice
rectangular prism looks like to me.
Yes, exactly. I do notice that the centers seem to be lined up here. It's not oblique. Now, what do you notice about this next one?
That one looks like an oblique.
Yeah, because if I drew down a height, not that that's very straight, it is definitely not meeting one center to the other center. Okay. So this would be oblique. So we could have right or oblique.
And then the last one is just, it looks like to me a right cylinder.
A right cylinder.
Especially since the height is even labeled going from the center to a center.
Right. Now, here's what they're saying. If this big B, if this area of this base is the exact same as the area of this base, and it's the exact same as the area of this base, and so they have the same cross-sectional area at every level, and they have the same height. Notice these all had the same height. Then all of these solids would have the same volume.
Okay.
Okay? And that's the idea of Cavaliere's principle. So really, we can even talk about volumes of oblique figures as well.
Okay, because what I'm thinking, when we talked about surface area, it only involved right prisms. I was about to ask that question. So because, and I'm already looking, I'm kind of looking ahead, I see it's volume of just a prism. So it could be a oblique or right prism. That formula works for any prism out there.
You got it.
But with surface area, it had to be specifically a right.
Exactly.
Okay.
Okay? Now, one thing that we want you guys to realize, the volume of a prism, this big B must mean the what?
Area of the base.
Area of the base times the height of the prism. And again, where is the height?
The height in a right prism would be like a lateral edge, but the height is just the perpendicular distance between the bases.
Love that.
So essentially, if you can find out how much area is on one of the bases, and if you know basically the distance between those bases, that's basically how much stuff is inside. Kind of get a visual of that. So if you know how much is at the base, and you multiply it by how tall it's going to be, that's how much volume is inside.
Exactly. I used to always use like Oreo cookies as a good example. You know, when you're looking at, and it's getting more to the cylinder, but if you find that area of that base and I keep stacking my Oreos on top of each other, you're going to eventually be able to count the height too, and you know that volume with all the Oreos in that kind of tower of Oreo cookies. All right, and that would work with any, anything that you stack on top. You're counting that layers that you have is really what you're doing. All right, so that is our volume of a prism. Nice, easy formula. Compared to surface area, a lot of people love volumes.
It's only two unknowns, basically.
Right. Volume of a rectangular prism, same thing. Area of the base times the height. How you find that base area will depend on what shape we're talking about.
Now, if it's a rectangular prism,
Uh-huh.
the base is a rectangle, so that means you can just do length times width. So a lot of times you think volume is length times width times height. That's a formula that you've learned even before here. It only works for rectangular prisms, but that's what makes rectangular prisms kind of unique.
Exactly. All right, volume of a cylinder, be careful, it's still area of the base times the height. So same idea, but what is the area of the base here?
Pi r squared, it's a circle.
Pi r squared. And so you could just say, instead of saying area of the base, which again, I would be a fan of just leaving it as area of a base, but make sure you know that that's a pi r squared times the height.
So what I'm noticing, kind of like surface area, prisms and cylinders have the same volume formula as well.
They do.
So in the end, we're not learning a bunch of different ones. We're learning a lot of similar ones. So that's kind of cool.
Yeah.
All right, let's apply it. Now, guys, again, when you're reading the directions, make sure you know what you're finding and what formula you're using. So it says, find the volume, so I know I'm dealing with volume, of a right prism. Now, we know that the volume formula works for any prism. So you might ask yourself, well, why are they telling you it's a right prism? That might communicate something to us, okay?
Okay.
So my formula for volume of any prism is?
Area of the base times the height.
So I need to find the area of the base and the height. We still need to know, if it's a prism, guys, we still need to understand what is the base, and then we obviously need to know what the height is.
Right.
Okay? Now, I want to go back to this idea of why it's a right prism. Why do we have to know that?
Well, because they didn't really mark on here that anything is perpendicular when I'm talking about lateral edges.
Between the two bases.
So between the two bases. So the fact that it's a right prism, that tells me that all of those rectangles are coming into that triangle base at a 90-degree angle.
Okay, so that means basically
that lateral edge.
The lateral edge. So when it's a right prism, the lateral edge is your height. Okay, so that means what's the height?
3.
Okay.
And just be really careful, guys, because I have a lot of people that I've noticed that when they see height, they will sometimes think height of the base. The height of a prism is what connects those bases.
Exactly.
Be careful with that.
Okay, now you already mentioned something I was going to ask is, since we're talking about a prism, we need to know what the base is. What's the base of this?
The bases here are the triangles.
So it's basically this piece right here.
Right.
And even more specifically, it's a
right triangle.
Right triangle. Now, right triangles are kind of convenient because we know the legs are perpendicular to each other. So that basically tells us what are these pieces when you're talking about area of a triangle.
Well, we know that the formula for area of a triangle would be 1/2 base times height, and there's your base and your height because we see that perpendicular, so we know that is the height of that figure.
So let's find that base area. And guys, if you want to redraw just that right triangle, I'm not going to worry about it since I can kind of see it here easy. So I'm going to do 1/2 the base times the height.
And I just want to point out while she's writing this down, notice that how Mrs. Palermo labeled what she's finding here. She wrote B equals, the big B, knowing that that's the area of the base equals this. Guys, I've started seeing some people who are not doing that on their homework.
Yeah, they have like just work everywhere.
Just work everywhere. And it is near impossible for us to follow all of that work. Clearly label your work.
Help us out, guys.
We're trying to give you points.
That way we can help you guys out too.
Yes, and it'll make it easier for you to find those pieces later if you know what they are too.
All right, so I would do 1/2 of 6.
Yeah,
so that's 3, and then multiply that by 2.5. What are we getting?
3 times 2.5 will give us a 7.5.
All right, I have the height already. I have the base area. Now I can just go ahead and find the volume. This is, again, notice how quick that was. So 7.5 times 3. So my total volume would be?
Let's see, 7.5 times 3 is going to give us a 22.5.
And this is?
This is millimeters cubed.
Perfect.
All right. For this next one, we have a cylinder.
Okay.
And they ask us to find the volume of a right cylinder. Now, let's start off with volume of any
cylinder.
Any cylinder or any prism is going to be what?
Volume equals area of the base times the height.
All right. Again, notice we're still writing that down every time too. It's nice to be able to just, I know the formula, let's write that down. Now let's fill in the pieces. Okay. They told us again, it's a right cylinder. Why is that important?
Well, that communicates the height usually. So I look at the picture and the height's going to be that 13.
Exactly.
It's not really a lateral edge because edges are not in cylinders, but that distance is going to be the same from the center of the base to the other center.
Right.
Like that's going to be the same distance.
Exactly. Because if it's a right, we know that those are connecting to be perpendicular. Okay, to the bases. Let's fill in the pieces. We know the height. We don't know the base area yet, though.
Okay.
So how could we find that?
Well, area of this type of base is a circle, so it'd be pi times the radius, which is 4, squared. So that's going to be a 16 pi. And I'm just going to leave it like that.
I think that sounds good. Let's leave it until we get our answer, because they do give us units here, so we know we're going to get a decimal, and that's okay. So volume is equal to, we had our base area was our 16 pi times our height, which we said was 13. And you could multiply the 16 and the 13 first if you want to simplify that.
And I'm going to go ahead and do that. So that's going to be 208.
208.
208 pi. And then I'm just going to take that times pi, and I get approximately 653.45. Now, guys, the reason why I like that Ms. Hogre just left the base area as 16 pi, because what I'm noticing some of you doing is you're rounding, and then you're using another rounded answer to find something else, and then you're having to write down all this decimal stuff. Look how much simpler. That's the whole point. Leaving something in terms of pi is just a simplified format, okay?
Right,
Unless
and if we
really
didn't have units, this is the exact volume. Now, what are our units here?
These are feet cubed.
Feet cubed, good. All right.
All right, this next one says, this rectangular prism has a volume of 396 cubic centimeters. Solve for x. Now, here's the deal. I see it's a rectangular prism.
So we know the formula.
And I see something about volume. Now, volume of any prism is?
Area of the base times the height.
Okay. Now, because it's a rectangular prism, we could also use the length times width times height. It's just kind of up to you. All right. Which formula do you want to use, Ms. O'Graby? I'll let you make the call.
Well, I'll tell you what. Because it's a rectangular prism, sometimes it's hard to tell which one's going to be our base.
Okay.
Because we could really use any of those rectangles as our base.
Okay.
So let's go with length times width times height, so I don't have to specify it right now.
And I'll go back to kind of stress, like, how could you determine? Because there's some of you, I noticed just the other day with rectangular prisms, we had some issues with that. So basically, since it's rectangular prism, length, width, and height are basically some of your edges. Okay?
Right.
So what would I multiply together?
The x times the x times the 11.
And we know, well, the volume was 396. So I'm going to put 396 equals, let's simplify this over here.
Okay, so 11, and I know x times x would be an x squared.
Not 2x.
Yeah.
11 x squared. And then to solve this, I'm going to divide by 11, right?
So 396 divided by 11, which is going to give us a 36. So then x by itself, if I take the square root to undo the square, would give me a 6.
And usually when you take the square root,
it should be plus or minus, but I know that it's a side length. So I'm not going to worry about the negative scenario.
And this is centimeters, so I'm going to squeeze that in there. Now, if I was using this formula instead, something that could help, and this is something I really stressed with my students the other day, is draw the rectangular base, all right, and label the dimensions you want to use, okay? Now, because all of these are rectangle faces, you could have any of them.
Right.
You could have this one as the rectangular base, so x and 11, which would make the height what?
The x.
This right here.
So you'd end up taking 11x times another x, which gives you the same thing, 11x squared.
Yeah, so this would be 11x, and then you multiply that by x, you're going to still get the same outcome, all right? You could use this right here as your base, okay? And notice if I do that, x and x, what would the height be?
The height would be 11 then.
Be 11, because this would be your base, this would be your base, so it's the perpendicular distance between them. And this base area would still be the x squared, and then you multiply that by 11. So you're still going to get the same outcome.
Right.
Okay, don't let rectangular prisms trick you guys.
All right. This one says find the diameter, so now we're going to, again, be working backwards, of a cylinder who has a volume of 277 cubic feet and a height of 5 feet. Notice again, we don't have a picture here.
Okay.
We don't really need one necessarily, but I do see that we're finding volume of a cylinder, so let's talk about that formula.
Well, it's area of the base times the height.
What do they tell us about base?
They give us, they don't give us anything about
They don't
base.
tell us anything, because what we're finding is the diameter, which is what we need to be able to help us define, well, really radius, but you know, that's a piece that we could use to help us define that area of the base. So maybe before I go straight to finding the diameter, why don't we find the area of the base?
Okay.
Does that sound good?
That sounds good.
Because they give us the volume.
Okay.
And they give us the
So that our unknown in this equation essentially is the base area, but that can help you find the diameter.
You got it. All right, so they tell us the volume is 277. We don't know the base area yet, but we do know the height is
5.
5.
So I'm just going to divide each side by 5. So 277 divided by 5. So the base area is equal to 55 point. This is exact.
Oh, yeah, that's right.
55.4.
All right, now, this is the whole base area. What is area of a base?
Pi r squared.
So I could say pi r squared is equal to 55.4. Now, be careful because this is only helping me to find the radius.
Yeah.
So we're not going to be done until we find the what?
Diameter.
In fact, I'm even going to write that off to the side. Diameter equals what? That's
Okay.
what I want to fill in.
But once I find the radius, I can just double it.
Right.
Okay. So I'm going to I'm trying to solve for r, so let's divide each side by pi.
Right. Oh, the exponent will be the last thing we touch. And here we're not going to be able to just write a simplified answer. We're going to go ahead and get a decimal, and that's okay.
So r squared,
It's frozen.
frozen on you,
Yep.
is approximately 17.6344. Now, leave that in your calculator, guys. We've gotten really
Right.
good at this. I'm gonna take the square root because I'm undoing a square, not a cube root. Okay, so I'm gonna take the square roots and the answer recall button, and the radius is approximately 4.1993. And then we said to get the diameter, we're just gonna take that times 2. And then the diameter ends up being, if we're rounding to the 100th, it would be 8.40.
Sounds good.
And
So,
this is in feet.
8.40 feet. Love it. Notice that this one, we didn't go straight to finding diameter. And that's okay. Fill in the pieces that you can and see what's unknown in your formula. But
Okay.
chances are that may help you to be able to then find a missing part that you were trying to look